Hello everyone. Today we will discuss the examples on directional derivatives. First example is find the directional derivative of xyz square plus xz at 1 comma 1 comma 1 in the direction of the normal to the surface 3xy square plus y is equal to z at 0 comma 1 comma 1. So here in this example they give the two surfaces, but for this surface we find the directional derivative at 1 comma 1 comma 1, and for this surface you can find the unit normal vector. So first you have to take this function, that is phi of xyz is equal to C form, so that in this surface we can find the normal vector at 0 comma 1 comma 1, means that is n bar. So E bar is equal to n bar by modulus of n bar. So after that you can find the del gradient of this function at 1 comma 1 comma 1. If you multiply both, means formula for the directional derivative is del phi or del f dot E bar. So that's why first you have to find the normal to this surface, because of find the directional derivative of xyz square plus xz at 1 comma 1 comma 1 in the direction of the normal to the surface. In the direction of the normal to the surface 3xy square plus y equal to z. So that's why you can find the normal to this surface. That's why first I am taking f of xyz is equal to 3xy square plus y minus z. That is, it means this equation right for equal to 0, then that function is called f of xyz. That's why I write here 3xy square plus y minus z. So after that find E bar at 0 comma 0 comma 0 comma 1 comma 1. So that's why first you have to find the three partial derivatives of f, that is dou f by dou x with respect to x, means 3y square is constant, x derivative is 1, so that's why 3y square plus y derivative 0 minus z derivative 0. Next dou f by dou y with respect to y, 3x is constant, y square derivative is 2y, 3x into 2y is 6y plus y derivative is 1, so plus 1 minus z derivative is 0. Next dou f by dou z with respect to z, 3xy square derivative 0 plus y derivative 0 minus z derivative is 1, so minus 1. Next del f, gradient of f is equal to formula I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z, that is 3y square I bar plus 3xy plus 1 j bar minus k bar. So after that del f at 0 comma 1 comma 1 is, means here x value 0, y value 1 and z value also 1. So that's why 3 into 1 square I bar plus 6 into x value 0, y value 1. Here you can substitute y value 1 plus 1 j bar minus k bar. So now this value becomes to 3i square plus, here it is 0 plus 1, 1 j bar minus k bar. This is n bar, normal to the surface. So already we discussed how to find the normal to the surface. So normal to the surface find by using del phi. So that's why we find del f, given function we consider as f. So that's why we find here del f, gradient of f, and point also given. So that's why we substitute the point in del f. We get the normal vector to the given surface, that is 3i bar plus j bar minus k bar. This is called n bar, normal vector. That's why we can define by n bar. So then E bar, unit normal vector, E bar is equal to n bar by modulus of n bar, that is 3i bar plus j bar minus k bar by under root of length of this vector, that is under root of 3 square plus 1 square plus minus 1 whole square, means I bar coefficient whole square plus j bar coefficient whole square plus k bar coefficient whole square under root of, that is equal to 1 by 9 plus 1 plus 1 under 1 by under root of 11, 3i bar plus j bar minus k bar. So we finish only one part, that is unit normal vector E bar we find. So next function we have to consider as g of x, y, z. So for which surface we have to find the directional derivative. That surface is take as g of x, y, z, that is x, y, z square plus x, z. Del g, again you have to find the gradient of g. Del g equal to I bar dou g by dou x plus j bar dou g by dou y plus k bar dou g by dou z. So dou g by dou x with respect to x, x derivative 1, yz square is constant. So yz square plus x derivative 1 into z plus z dou g by dou y. So here x z square is constant, y derivative is 1. So x z square dou g by dou z. So here x y is constant, z square derivative is 2z, that is 2xyz plus z derivative is 1. So 1 into x plus x. So again we have to substitute these values in del g. After that substitute the point 1 comma 1 comma 1. Why we substitute 1 comma 1 comma 1? We have to find the directional derivative for x y z square plus x z at 1 comma 1 comma 1. So that's why we can substitute the 1 comma 1 comma 1 in del g. So that's why we can substitute it. We get a vector at 1 comma 1 comma 1, that is here x value 1, y value 1 and z value 1. You can substitute 1 square plus 1 and next j bar into x, because of we are already substituted dou g by dou x, dou g by dou y, dou g by dou z, and in that x y z we can substitute 1 comma 1 comma 1. We get 2i bar plus j bar plus 3k bar. So this is a del g. So now going to write the formula for the directional derivative. Directional derivative of the given function or given surface in the direction of E bar at 1 comma 1 comma 1 is del g dot E bar, that is 2i bar plus j bar plus 3k bar into 1 by under root of 11 into 3i bar plus j bar minus k bar. We are substituting del g value and E bar value. After that 1 by root 11 is constant and multiply two vectors by using the rules I bar dot I bar is 1 and I bar coefficients are 2 and 3. 2 into 3 6. Next j bar dot j bar coefficient is the E value is 1. So here coefficients are 1. So that's why 1 into 1 1 minus. Why we write minus here? Plus 3 is there, here minus 1 is there. So 3 into minus 1 minus 3, that is equal to 7 minus 3 4 by root 11 is the directional derivative value. So going to the next example. Find the directional derivative of the function f is equal to x square minus y square plus 2z square at the point p equal to 1 comma 2 comma 3 in the direction of the line PQ where q equal to 5 comma 0 comma 4. So here in the given problem find the directional derivative of f at p equal to 1 comma 2 comma 3 in the direction of the line. They are giving in the direction of the line PQ where q equal to 5 comma 0 comma 4. But here we need the value for PQ, means line PQ. That's why we can use the first OP line, OQ line by using the curve. Here AB is one curve, that is a curve with a sphere of center at O, that is all of you know x square plus y square plus z square is equal to a square, r square is a sphere with radius r. So based on that, if you take a sphere, and from that sphere we can take one part, that is AB. So here O is the center of the sphere. So OP is one line and OQ is one line. From that part of AB we have to consider PQ. So in the direction of the line PQ, in the direction of the line PQ, then we can find the directional derivative. So how to find the line PQ? So OQ minus OP is called OQ. So that's why we can using this concept, then we can find the PQ bar, means line of PQ, that is PQ bar equal to OQ bar minus OP bar. So That is how to find OQ bar and OP bar. Here O is a 0 comma 0 comma 0 because it is center, so that's why OQ bar minus OP bar. First OQ bar is right from the given vector is 5I bar plus 4J bar. So here Y bar coefficient is Y coefficient is 0, so Y value is 0, that therefore J coefficient is 0, so that's why we are getting only 5I bar plus 4K bar. Next OP bar, by using OP bar means how to find the OP bar. Here X value 1, Y value 2, Z value 3, so that's why we can write I bar plus 2J bar plus 3K bar is OP bar. The position vectors of P and Q with respect to the origin. So these two are called position vectors. OP bar and OQ bar are the position vectors of P and Q. So that's why we can write OP bar and OQ bar from P and Q. Finally, we can write the PQ bar is equal to OQ bar minus OQ bar minus OP bar. So then we can get 5I bar plus 4J bar minus I bar minus 2J bar minus 3K bar. We get PQ bar is equal to 4I bar minus 2J bar plus K bar. So by using the concept of line PQ, so we can get a normal vector. For that normal vector, you can find a unit normal vector by using E bar formula. That is, E bar is equal to 4I bar means PQ bar by length of the PQ bar. That is, E bar is equal to 4I bar minus 2J bar plus K bar by under root of length of the PQ bar is 4 square plus minus 2 whole square plus 1 whole square. So then we can get E bar is equal to we get the value is here under root of 16 plus 4 plus 1, that is root 21 into 4I bar minus 2J bar plus K bar. So next one is we can find the del F. Given F is x square minus y square plus 2z square. So del F is equal to I bar dou F by dou x plus J bar dou F by dou y plus K bar dou F by dou z. So with respect to x, derivative of F is 2x. That's it. Remaining terms derivatives are 0. Next dou F by dou y is minus 2y, x square derivative 0, 2z square derivative 0, and plus K bar dou F by dou Z. So with respect to Z is 2 into 2Z, that is 4Z. Substitute all the values in the del F and we can find the directional derivative at P. P is 1, 2, 3. Substitute x value 1, y value 2 and z value 3. We can get 2I bar minus 4J bar plus 12K bar. So now going to find the directional derivative of the formula E bar dot del F. So the directional derivative of F bar at P in the direction of PQ bar is E bar dot del F, that is 1 by root 21 into E bar 4I bar minus 2J bar plus K bar into del F is 2I bar minus 4J bar plus 12K bar. So now 1 by root 21 into 4 into 2, 8. Minus 2 into minus 4 plus 8. Next 1 into 12 plus 12, we get 28 by root 21. Here it is also one of the different problem to find the directional derivative. So they are asking the find directional derivative in the line of PQ, but they are giving the points P and Q. So we are considering P and Q are the position vectors of position vectors of PQ are OP and OQ. O is the center of the given curve, means that we always consider a curve is x square plus y square plus z square is equal to r square. So that is a sphere. So that's why we can consider O and OP one position vector, OQ is another position vector. We find PQ equal to OQ bar minus OP bar. By using this concept, then we can find the PQ bar and find the directional derivative in the direction of PQ bar. So next example is find the greatest value of directional derivative of the function f is equal to x square y z cube at 2 comma 1 comma minus 1. So the greatest value of directional derivative of the function is modulus of del f, or length of the del f is called the greatest value. So that's why you have to find the del f and substitute the point 2 comma 1 comma minus 1 after getting the vector. So then you can find the length of that vector or modulus of that vector, that is called the greatest value. So that's why find first del f. F is equal to x square y z cube. Del f is equal to I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z. So first I bar dou f by dou x, y z cube is constant, x square derivative is 2x y z cube plus j bar into dou f by dou y, y derivative is 1 into x square z cube, so x square z cube into 1 plus k bar into dou f by dou z. Here x square y is constant, z cube derivative is 3z square, so that's why 3x square y z square is dou f by dou z. Now substitute the point in del f. Del f is at 2 comma 1 comma minus 1, that is x value 2, y value 1, z value minus 1. You can substitute the values 2 into 1 into minus 1 whole cube plus j into x value 2 square, z cube value, z value minus 1 whole cube plus k bar into 3 into x value 2 whole square, y value 1 into z value minus 1 whole square. We get the value is minus 4i bar minus 4j bar plus 12k bar. So greatest value of the directional derivative of f is modulus of del f, or length of the del f, that is under root of 4x square plus y square plus z square. Here x value is minus 4 plus y value is also minus 4 whole square plus z value is 12 whole square, that is under root of 16 plus 144 under root of 176, that is 176, right? Also like 16 into 11 means 16 into 11 value is 176, that is, so root of 16 is 4, so that's why we can write 4 into root 11. So this is the value, greatest value of directional derivative of f. So next one is, in what direction from the point minus 1 comma 1 comma 2 is the directional derivative of phi equal to x y square z cube a maximum? What is the magnitude of this maximum? So the magnitude of this maximum is also a length of the grade phi, or means modulus of the del phi. So means you can take phi and find the partial derivatives with respect to x, with respect to y, with respect to z. After that find the del phi, the directional derivative of maximum in the direction of del phi, and the magnitude of maximum is modulus of del phi, or length of the del phi. So if they want to find the greatest value or maximum of the magnitude, same formula, that is modulus of del phi or del f or del g function, for any function you can find the gradient and find the length of that function or modulus of that function. First we have to see that the given function is phi is equal to x y square z cube. So dou phi by dou x is y square z cube, x derivative is 1. Dou phi by dou y is y square derivative is 2x y z cube. Dou phi by dou z is x y square is constant, z cube derivative is 3z square, so 3x y square z square. So now find the del phi. We know that the vector del phi along the normal to the surface phi of x y z is equal to c at a point P of x y z. First we have to find the normal to the given surface, that is del phi. So write the formula I bar dou phi by dou x plus j bar dou phi by by dou y plus k bar dou phi by dou z. Substitute the dou phi by dou x, dou phi by dou y, dou phi by dou z, and del phi at minus 1 comma 1 comma 2 is, means x value is minus 1, y value is 1, z value is 2. Then substitute it, y value 1, 1 whole square, z value 2, 2 cube into I bar plus 2 into minus 1 into 1 into 2 cube j bar plus 3 into minus 1, 1 whole square, 2 square k bar. So then we get 8 I bar, 2 cube is 8. Here 2 cube into 2 into minus 1. So that is minus 16 j bar. Here 3 into 2 square. So minus, again here minus 1 multiply with that. So it is minus 12 k bar. So after that, the directional derivative is maximum in the direction of del phi, and the magnitude of this maximum is modulus of del phi, or length of the del phi, that is under root of x square plus y square plus z square. Here x value 8, y value minus 16, and z value minus 12, that is 8 square plus minus 16 whole square plus minus 12 whole square. So 8 whole square 64, minus 16 whole square 256, minus 12 whole square 144, that is under root of 464 is the magnitude of this maximum. Next one is find a unit normal vector to the surface z is equal to x square plus y square at minus 1 comma minus 2 comma 5. So unit normal, how to find the unit normal? Unit normal means E bar. First find the normal to the surface, substitute the point, we get a normal vector. For that normal vector you can find the unit normal, that is E bar is equal to n bar by modulus of n bar. Or simply we can write if the function is considered as f, del f by modulus of del f. Any one is a formula for the unit normal. So let f of xyz is equal to x square plus y square minus z. You can write in the form of phi of xy, or f of xyz is equal to 0. So that's why x square plus y square minus z is equal to 0. So f of xyz is equal to x square plus y square minus z. So find the dou f by dou x, that is 2x, dou f by dou y, that is 2y, dou f by dou z minus 1 because of x square derivative 0, y square derivative 0, minus z derivative is 1, so that is minus 1. So now substitute in del f I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z, that is del f I bar dou f by dou x is 2x plus j bar dou f by dou y is 2y plus k bar dou f by dou z value is minus 1. Then substitute the point, that is minus 1 comma minus 2 comma 5. So x value is minus 1, y value is minus 2, and there is no z terms, so that's why we can substitute only x and y. I bar 2 into minus 1 plus j bar 2 into minus 2 minus k bar, that is minus 2 I bar minus 4 j bar minus k bar. So now you can find the unit normal vector, that is E bar equal to n bar by modulus of n bar, or directly we can write from del f, that is del f by modulus of del f, that is minus 2 I bar. Here del f is minus 2 I bar minus 4 j bar minus k bar by under root of minus 2 whole square, because of x value is minus 2, y value is minus 4, and z value is minus 1, minus 2 whole square plus 4 plus minus 4 whole square plus minus 1 whole square. We get the value is, here common negative sign, all are the terms with the negative sign, so that's why we can common minus 1 by 4 plus 16 plus 1, so that is 21, root 21 into 2 I bar plus 4 j bar plus k bar. That's all for today.